Hello again. Welcome back. Today is part 2 of our lesson involving finding volume of rectangular prisms, this time with a little bit of capacity work thrown in, particularly in the beginning. To start things off, there was another page that came before this one that had a few more examples. There is one at the top of this page that covers finding volume of this hot tub, for example. But for us, we're going to just jump right into this. If you have not had a chance to look at the first picture, at the first page, go ahead and stop this video and go back to Google Classroom and look at that first page. It will help immensely. But assuming you have already looked at that, we'll get started with number 1. It is asking us to find the volume of each rectangular prism. Now, number 1 and number 2 are very straightforward. You simply have to count up what is the length, width, and height. So, counting up my length, we have 1, 2, 3, 4. For my width, we have 1, 2, 3, 4, 5 cubes going to the side. And we have 1, 2, 3 cubes tall. So, my volume for shape 1 is going to be 4 times 5 times 3. You may be able to do this one in your head. If you can, congrats. If not, this is calculator active, so you can use this to assist you. But back to the main point, the answer is going to be 60. And since it did not specify a unit of measurement for this problem, we're just going to leave it as 60 units cubed. Since we don't know what measurement we are going with, we're just going to write that it is units cubed, so that if this were a real-world situation and, say, an architect or engineer gave us a set of blueprints and failed to mention to us how large each cube is, we would simply write units cubed and then let the engineer know, you messed up, we need to know what size units we're doing because that changes what this problem means. Because if those are 60 miles, this problem is going to be rather impossible, having cubes that are a mile high stacked on top of each other. If it is inches, centimeters, feet, that's a bit more doable. Back to the problems at hand, number 2 has a width or length of 4. The other dimension is also 4. And the final dimension is also 4. That means this is not a prism, technically. This would be called a cube, since all of the sides are going to be the same. Now, one thing I'm going to pause and let you know, this does not look particularly perfect like a cube. It does look like it's stretched out a bit. This is why it's important, especially in this particular unit, not to trust your eyes. Do not trust your eyes when you are looking at a math problem like this. Instead, you need to be trusting the numbers that are on the paper. You need to be trusting what is represented in your paper. If you start making assumptions and just say, oh, this one's a cube, or oh, this one's not a cube, you could end up getting problems wrong for very silly reasons. Number 2, 4 times 4 times 4, or 4 to the third power, is 64 units cubed. There are 2 answers so far. Number 3 is a bit different. It does not specify that the side lengths are equal to 1 unit. This time they specify 1 cube is going to be 1/7 of an inch in each direction based on this chart. So we can say, okay, so this is going to be 1, 2, 3, 4 1/7 inch cubes. Well, you could write out 4 times 1/7, but I think you can picture 1/7, 2/7, 3/7, 4/7. As for the base, or the length, we have 1, 2, 3/7. And for the height, oh, we've already done the height. For the width, we have 1, 2, 3/7 again. You are welcome to do this without a calculator, but as I have mentioned, for problems like this, you are already doing a lot of heavy lifting by setting up this problem. It's not necessary to try to beat yourself up and do this in your head. so we can use a calculator to assist us. We have 4/7 times 3/7 times 3/7 again. Check and make sure that's right and that the glare isn't in the way. And we get our answer of 36/343. Now, your calculator should automatically be simplifying this to simplest terms, so we can trust that that is likely accurate. So, we have 36 out of 343, and that is going to be inches cubed for number 3. Number 4 follows a similar problem, and I should mention this is the difference between volume and capacity. In volume, it is understood that one section is equal to 1 unit. For capacity, those sections may not be equal to one whole unit. These could be fractional, or they could be more than 1. For number 4, our height, each cube is measured by 1/8 of a meter. So we have 1, 2, 3, 4 eighths of a meter in height, 1, 2, 3, 4, 5 eighths of a meter in length, and 2/8 of a meter in width. Now, if you really wanted to, you could take some time and simplify that and before punching them in. However, your calculator is not going to care what you punched in, and at the end of the day, we can always simplify in the end. There is no point in simplifying now and later. It just doesn't make sense. It's like flossing before you brush your teeth. Why are you going to do that? Because you're going to have to floss again afterwards. Anyways, we have 4/8, 5/8, 2/8. So we have 4/8 times 5/8 times 3/8. Sorry, 2/8. That gives us 5/64. 5/64 of a meter cubed. All right. That's it for the first page. Moving on. Our second page is going to be numbers 5 through 10. Now, this side is going to be a little bit easier than the other, in that the vast majority of these are simply asking you for you to find volume. So, assuming that you have already done this, I am going to forego a lot of the explanation, and I'm just going to work through this worksheet, and we'll see what we get. For number 5, we have 16 to the third power, because all three lengths are the same. That will be 4,096 inches cubed. Number 6, that is going to be 3 times 8 times 4.2, which is 100.8 centimeters cubed. Number 7 is 7.5 times 1.5 times 3.5, and that gives me a volume of 39.375 thousandths feet cubed. For number 8, we have 6 to the third power. That will give me 216 feet cubed. That was correct, right? Yes. For number 9, we have 20 times 15 times 16, which gives me 4,800 feet cubed. For number 10, how many cubic centimeters are needed to make this wax? We have 5 times 5 times 14. So 5 times 5 times 14 will equal 350 centimeters cubed. And for the final two questions, it says Victor's pouring a concrete patio. How many cubic feet of concrete will he need? Explain how you found your answer. Well, we followed the formula for volume, which is volume equals length times width times height. That's our explanation. So we did volume will equal 0.5 times 12.9 times 20.45. 0.5 times 12.9 times 20.45. So the volume will equal 131.9025 feet cubed. For number 12, Carrie made this rectangular prism from her box. What is the area of the prism? And explain how you found your answer. I don't believe that they meant to ask area. They could have meant surface area, but this unit is referring to volume. So that is what we will explain for this problem. For starters, we have a height that is 3/5 of an inch tall. We have 1, 2, 3, 4, 5. We have 6/5 of an inch long. And we have 2/5 of an inch wide. So for our explanation, each cube represents 1/5 of an inch. So we combined the cube lengths for the length, width, and height before finding volume. So then we're simply going to do 3/5 times 6/5 times 2/5. And that should give me 36 125 of an inch cubed. And that's all. That's everything that this worksheet covered. It was just 12 simple practice problems covering finding volume with a little bit of capacity. And that's all. See you next time.